Hey, welcome back everybody. It's another Ask Mark video here at Blue Glow Electronics. So I've got this email here from Bill, and he and I have swapped a couple back and forth attempts at it, and I thought, it might just be easier to make a video to explain this one. He basically says, hey Mark, thank you for stuff you've done in the past, and I love your videos. Then he went on to say, however, recently I came across an issue, and I thought I'd reach out to you on your thoughts because I can't seem to find an answer anywhere. He said, I just restored a Scott 222C, and after watching your 4-part video, it turns on and sounds incredible. But the ceramic cement resistor above the chassis gets wicked hot. It says, I just measured it after 20 minutes, and it was 350 degrees. That seems too hot for me. By any chance, do you happen to know if this is within its operating limits? I figured since you have a Keeper 222C based on the video, you might know how hot it gets. Thanks ahead of time, Bill. Okay, first things first, let's pull up the schematic here and see if we can locate this resistor, kind of understand what purpose it's playing in the amplifier. So right here is R212, and this is the 8K stick resistor that is in question at this point in time. So let's back up over here a little bit and understand what we have going on. So we've got our input power outlet right here, right? Plugs into the wall. And from there we go into our transformer, right? And we take our 110 voltage and we bump it up to a much higher voltage through the transformer. Then next we go through this rectifier. In this case it happens to be a 5AR4. And so the other side of this, coming out of pin number 8 here on the 5AR4, if you'll notice, we have 430 volts at this point, okay? And theoretically, this is rectified at this point, but it has not been filtered yet. And then what happens is we just go through a series of C, R, C, you can see here, CRC. We go through a series of one CRC after another CRC after another CRC. And what we're doing with each one of these steps is we're dropping the voltage down a little bit through these dropping resistors. And you can kind of see here, you start out with 430 volts. And as it moves along to the next leg here, it's at 420 volts. As it jumps across this one and comes out, you're at 330 volts. After you jump across this one, you're down to 300 volts. And then finally, after this one, 285, and then 220 volts. And these feed various points throughout the amplifier that need different voltages. It's the purpose of all this. But if we'll kind of come back here to this 8 ohm resistor and start following it a little bit, okay? First and foremost, it kind of feeds over to here. Then it comes up and it ties in right here with what is a 1.2K 10 watt resistor right here, okay? And then we come out the other side of it and we come down and we feed into, we kind of feed here into what I'll call this power rail line that feeds over right here, right? And then ultimately feeds in at 420 volts. So if you think about it, the way this kind of lays out, 420 volts that's been rectified then at this point, and we've gone through a CRC filter, so we should have fairly smooth DC at this point, feeding back across over here and feeding into a 1.2K 10 watt resistor. Then we come out the other side of this resistor here, and we come down and we feed into this 8K resistor. From there, we feed to this point right here. And don't get confused thinking that all this 8K resistor feeds into the stereo balance pot. Not really. What it really does is it ties into this point that goes up to ground. And it just happens to be the middle wiper on the stereo balance here is also tied to ground, okay? So, if you think about it, out of here, over into this resistor, out the other side of the resistor, down here to ground, okay? And so let me draw that for you. So what I've done now is kind of blanked out an area down here on the schematic that we don't need. And what I've done is redrawn this circuit. So basically here we have this 420 volt DC battery, we could think of it, sitting right here. Okay, and we'll consider this point down here ground. Okay, and we're feeding out of the battery into a 1.2K 10 watt resistor. We're then coming across going through an 8K 20 watt resistor. And what we really have going on here is a tap coming out of the middle of that. And this is nothing more than a voltage divider circuit. Okay, so if we scroll back up here and look at the actual schematic, what we've got going on is right, let me find the spot. If we go right here, you'll notice we're feeding out of this point over here, and we're feeding up into pin 9 of both of the 7189s. And if you'll notice, we're coming out of it down to here. We're also, feeding from here to here. We're feeding here over here. There again, same 345 volts. And we're feeding to both pins here of the pin 9 of the 7189 tubes. Keep in mind, these are the screens. So what you're looking for here typically in a push-pull amplifier pin-towed setup, when you where you have a screen, you will typically have a voltage. And if you'll notice here, we've got 420 volts sitting on the plates here. And what you want to have is a voltage slightly lower than that, some degree, which we have 345 volts sitting on the screens right here. And we need to establish this screen voltage somewhere in this circuit. Sometimes you'll see people use a resistor coming off of the plate, coming down to the screen. The problem with that is plate voltage varies, then the screen voltage varies, and we're trying to establish a solid screen voltage here. So we're actually using a power supply section to kind of pull that off of this 420. Then we're going through this voltage divider. So really what we've got going on here is this is feeding pin 9, pin 9 of the 7189 tubes, all four in parallel. So we're just feeding this, ultimate goal here is to get this 345 volts to the 7189 pin 9s over here. Okay, and this is as simple as the entire circuit gets. So back to the question here, this thing's getting mighty hot. Well, let's do some math. So we come back over here and take a look at our little scenario here. First thing I want to do is figure out the current flowing through this circuit here, just assuming that that there's no tubes connected to it here, because there's going to be very little current flowing through the screens on these tubes. So you just use Ohm's law, I is equal to V over R. I is equal to 420 volt DC here, divided by the 9200 ohms. That would be the 8K plus the 1.2K to give us 9200. We come up with 45 milliamps of current flowing through this circuit right here. And then we can do our power calculator, I squared R. We take our 45 milliamps and we multiply it times 2, and then we multiply that times 1200. And what we come out is this resistor should be dissipating around 2.43 watts. And then we're going to do the same down here for this resistor. We take our 0.045 milliamps, we square that. We then multiply times the 8,000 ohms, and we get that this resistor is dissipating 16.2 watts right here, okay? And yes, it is going to get very hot. And that is why they made it a stick resistor. It is why they put it up on top of the chassis, for it to be able to dissipate this heat, okay? So the next thing I did was sent Bill back an email and said, let's do some measurements on your circuit, right? And he basically said, hey, I set my variac to 117 volts. I measured across the resistor, the 8K resistor. It actually happens to be 8.15 in his. And he was noticing it has 387 volts across it at the top. And it comes out to be 48 milliamps. So not much different than the 45 milliamps we talked about. He did the power calculation. He came out with 18.8 watts. It's a 20 watt resistor. A little close, but I'll tell you why here in a minute. It went on to say, you know, I'm more worried that something may be off in my circuit, okay? Well, here's the reality, Bill. First off, you set your variac at 117 volts, right? Well, when these transformers were designed, your wall voltage was probably more in the 110 to 115 range, but could have been as high as 117. But I'll bet you if you unplug your 222C and plug it straight into the wall outlet, you probably get closer to 120 these days, which doesn't help our cause at all, because what it does is the voltage sitting here coming off pin 8 of this 5AR4 is probably not 430 volts. It's probably 460 volts, which is just bumping up all these voltages down the line here. So instead of having 420 volts feeding across coming in here into this 1.2K 10 watt resistor, and instead of having 345 volts right here, as you mentioned, we have 387 volts sitting here on this side. So if this were my amp and I was trying to make it last the years and run within spec, what I would do is I would come back here and I would adjust this 1.2K resistor right here that we've been talking about all along. Because if you increase this resistance a little bit, right, what you're going to put is more voltage drop across it. And what you're shooting for is adjust this resistor here until you end up with the 345 volts coming out of the middle of it, as per the kind of the spec sheet here. And once you get the 345 volts here, what you will find is you will be dropping more wattage across this resistor. And remember, we had a long ways to go, 2.43 watts here, and that's a 10 watt resistor. So let's say we end up dropping more like 4 or 5 watts here. Then what will happen down here, once you're at 345 volts, you'll be dropping less across this resistor here. And maybe the value goes down some. So the reality is there's absolutely nothing wrong with your amp. I would try to get this voltage a little more in line here at 345 volts right here. And it will help with the, like I said, the overall, voltage drop across, and the power dissipation across this resistor as well. So hope this helped you out. There's nothing wrong with your amplifier. These little stick resistors do get very hot, and that's why they mounted them on top of the chassis. The bottom line is you got a lot of voltage there. You're trying to do a voltage divider across it. You're trying to drop that voltage and pull off some of it in the middle to feed pin 9. And since there's very little current flowing out this way, almost every bit of it is coming straight through these two resistors, straight back to ground, feeding back into the battery here. So hope this helps, and thanks everybody for watching. Just let everybody know I am doing well. I have been focused on a bunch of other stuff, and I will be making a video on that soon. But we're still here, and I promise you we've been working on electronics. Just haven't been making videos on some of it, but you'll see the fruits of the labor down the road here just a little bit. So stay tuned, everybody, and thanks.